Question number 13 is another question where you're having to prove whether a particular object is, or a particular point has been rotated. It says point A, the transform point A, has been rotated about the point B by a clockwise angle of 90 degrees. Verify using slope, distance, and or midpoint that the rotation of A is, or the A prime, the transformed A, is in fact the rotation of point A. So our goal is to prove that and verify that in fact this new point here has been or is simply the original point A rotated 90 degrees about point B. And it does clearly look like it, but in order to verify that we just need to test a couple things. So we need to verify two things to prove a rotation. So things we need to verify, and you may notice as we do this, we need to verify. A couple things you may notice as we do this is that some of the same things we use to verify that a point has been reflected are the same things that we use to verify a rotation as well. Okay, in particular with a 90-degree rotation. And as an example, for instance, if we look at the line that can be made by connecting A to B and B to the transformed point A, if it's a 90-degree rotation, that clearly is a 90-degree angle. So if it is 90 degrees, that means that the lines are perpendicular, and in order to prove two lines are perpendicular, we use the slopes of the lines, and we have to prove that the slopes are opposite reciprocals. Okay, so we need to verify that slopes, if I can get this to right without stopping on me, there we go. We need to verify slopes are in fact perpendicular. I'm just going to use the symbol for perpendicular because writing on this tablet is a little annoying at times. So prove that the slopes are perpendicular. So what I'm going to do is simply look at this from point A to point B, and just slope as change in y or change in x or rise over run. So if I look at this, this has a y of 5, and if I'm trying to get down to point B, that means I end up coming down from 5 down to a y value of 1, so that's a drop of 4. So the slope from A to B is equal to -4 as the rise, or the change in y, and the run, change in x, is simply going over 1. So -4 over 1, or just -4. Alright. Then I'm going to find the slope from B to the transform point A. Okay, so from B to the transformed A, and if I look at that slope, from B to A, that's a rise of 1, change in y is 1, and if I look in the x direction, I have to go from an x of 2 to an x of 6, which is a change of 4. So the slope from B to A, from B to the rotated A is in fact 1/4. And if we look, again, to prove slopes are perpendicular, we need to, or to prove that the lines are perpendicular, I wrote slopes here. But to prove that the lines are perpendicular, we prove that the slopes are in fact opposite reciprocals of each other. And what we mean by that is that the fractions that can be made out of the slopes, if we were to look at them, they are reciprocals. 4 over 1 is sort of the upside down of 1 over 4, and they have the opposite sign. This slope is positive, this one is negative. So in fact, the lines are perpendicular. Then the other thing we need to verify is that the distance has not changed from A to B as it is from B to the transform point A. In other words, point A, when we rotate it, can't get any farther away from point B if it's just a rotation. If it's gotten farther away, then that's a different type of transformation. That's a translation as well as rotation. Okay. So to verify that the distances are the same, that is our second step. So let me write that down here. So we need to verify that the distance hasn't changed from A to B. Okay? And in order to do that, we're just going to simply use Pythagorean theorem to figure out this oblique or slanted distance here from A to B. So the height of this triangle was 4, the width was 1. So if I use a squared plus b squared equals c squared, Pythagorean theorem, I have 4 squared plus 1 squared equals c squared. So the slanted side here will be the C. And if you work this out, 4 squared plus 1 squared is equal to 17. 16 plus 1. That equals C squared, so that means C is equal to the square root of 17, which is some decimal just a little bit more than 4. But since it's not nice, we'll just leave it as a radical square root of 17. And then we do the same thing here. Figure out the distance C here. And in order, if we look at this triangle, it's simply the same triangle that's been turned. This one has a width of 4 and a height of 1. So we still have 1 squared plus 4 squared equals C squared. And all we've done is just switch the places of these, so we're still going to get C is equal to the square root of 17. Okay, so we proved both things that we needed to. We proved that the distance has remained the same, and we proved that the lines are perpendicular to each other, so they do in fact make a 90-degree angle. Okay, so that's all we have to prove, and we are done with question 13.